Hello everyone, and welcome to this webinar on predicting employee attrition using Oracle Machine Learning, Oracle Application Express, and the Oracle Analytics Cloud. Hi, my name is Charlie Berger. I'm the Senior Director of Product Management for Machine Learning here at Oracle, and I'm joined by four other amazing people that are going to introduce themselves as we get to that. Derek Cameron, Devani Sheth, Sadesh Ujini, and Rosie Palmer. So I'll let them introduce themselves along the way, but together the team has done some absolutely great work here, and we hope to show you some cool things. The main point of what we're talking about here in this webinar is the power and the simplicity of Oracle's architecture, which is to not move the data, but for machine learning purposes, but move the algorithms, and that's what we've done. We've moved 30 plus algorithms inside the database as native functions that build predictive models, apply predictive models, and when you unleash the power of machine learning directly as native functions inside the database. They're also integrated and exposed to open source languages like Python and R, but when you bring the data scientists inside the database, it opens up a lot of opportunities. So we'll try and show you those possibilities now. Oracle always has a safe harbor statement that says sometimes we may mention something about a new feature and that don't hold us to that commitment. It's a rough time frame. So we always have to show that. And the goal of this session is to show how to solve a typical machine learning problem and provide a little bit more of a solution, right? We're not just a data scientist that's going to build a model, apply the model. We're going to take it a little bit further and show how you can then use those results in Oracle Application Express and Oracle Analytics Cloud. So I'm going to give a quick overview of Oracle Machine Learning. Then I'm going to hand it off to Derek, who's going to show the notebooks. Then we're going to hand it off to Rosie, Sadesh, and Devani, who are going to walk us through the how to build and do things with Oracle Application Express. And then finally, we're going to have Philippe Leon come in. We're all excited about this to get him on at the very end because it's a new feature, Oracle Analytics Cloud 5.7, and its integration with Oracle Machine Learning. And at the very end, we'll close up with some resources and links. So the Oracle database has, over the years, been adding a lot of new features and functions. The support for in-memory, support for JSON database types, support for XML, spatial, graph. The thing that we think is really pretty cool is the machine learning. So with the machine learning being part of this ever more capable converged database, now you can harvest more information, discover new insights, and in fact make predictions. So we're going to talk about the machine learning aspect here and assume that you already know about security, scalability, parallelism, auditing, backup, data encryption, all of those kind of aspects. So we'll talk to you a little bit more focusing on the machine learning and those new possibilities. The way we do this is using something called Oracle Machine Learning. It used to be a priced feature of the database, but as of December 5th, 2019, Oracle made this a free feature of all the databases. So it extends the Oracle databases and enables users to build AI applications and analytical dashboards that surface and expose predictions and insights and probabilities and reasons for those predictions. So in total then, Oracle Machine Learning delivers powerful in-database machine learning algorithms, automated machine learning functionality, and exposes that via, of course, the SQL and PL SQL, but also integration with open source Python and R. And as I said, I think the coolest thing about this is it comes with all of your licenses of your Oracle Enterprise Edition, SE2, and autonomous databases. It is an included feature, along with spatial and graph, which opens up even more possibilities. So let's take a look a little bit further. What we're going to focus on today is on the autonomous databases. So we're going to be over here in the upper right, up in the autonomous data warehouse, and autonomous transactional database. And we're going to use the Oracle Machine Learning notebooks to access that data. Coming very, very soon this fall is the integration with Python as well. So on the autonomous database, we will host Python. We will have preloaded packages for you to use. And the most important thing, I think, is people who speak Python can also speak Python to access the other 30-something machine learning algorithms that are inside the database as native functions. On-premise, just to be complete, we also have the drag-and-drop Oracle Data Miner graphical user interface that is a component of SQL Developer. We also have RStudio. When we have the integration with R, we probably want to use something like RStudio to drive the R language commands to those same in-database functions or to make callouts to R. And so regardless if you're on-premise or in the cloud, we have a various different type of user interface and API for you to use. I also want to point out in the middle, because of course, not all the data is always in the database. Sometimes it's in other locations, and I'd like you to consider that sometimes that data is raw, raw data of just measures of temperature, of gauges, and things. That's raw data that oftentimes needs to be aggregated and boiled down. So I always think if you're thinking about how you're going to solve a problem, you may have data that's all over the place, some in the database, some outside the database, but the data that might be out in Hadoop or another big data environments, maybe you need to boil that down and then bring in counts and totals and changes over time into and join with the rest of the data in the database, and then continue on with your machine learning algorithms. As far as algorithms that we support, we have quite a few. We're over 30 now. In terms of classification, we have several there: naive Bayes, logistic regression, decision tree, random forest, and so on. XGBoost is one of the new ones that we're just adding in the 20C release. In clustering, we have several different algorithms. Anomaly detection, we have the one class support vector machine, where you train on normal data and then you apply it to new data and you flag those things that are most similar to the training population. So that's a great algorithm. And we're adding another one, MSET SPRT, which is more designed for process monitoring. That's very, very powerful technique. We also have time series, multiple regression, attribute importance, and so on. The nice thing that I always like to point out in what we have with Oracle inside the database is the novelty of bringing algorithms inside the database opens up all these other new possibilities. So if I want to build a predictive model on who's likely to vote for candidate A or candidate B, and I want to partition those models by state or region, I can just do partition by state. If I want to partition by state and gender, I can do that as well, and I'll now in the United States have 100 different models. If I have transactional data, like in a medical claim situation, maybe I have the patient and their blood type and their temperature, but then I have all the medications they're on. Well, you don't want to store the medications and allocate a column for each one. Instead, you generally have those as transactional data, and you need to aggregate that. So that's the way the data is stored in the database. That's the way we can ingest that data into the algorithms. Similarly, for unstructured data, we would use Oracle Text to tokenize that data and bring in a vector of terms that join into the rest of the data, and that's the way we can ingest it. Similarly for spatial data, graph data, and so on. So it's not your classic machine learning kind of thing that you would get with R or Python. It is in the sense of the algorithms, but the algorithms can mine clobs, structured data, unstructured data, transactional data, and so on. And then we also have probably the tightest, best integration with open source out on the market with our Oracle Machine Learning for R and Oracle Machine Learning for Python, which both allow you to speak your native tongue, but to derive these same algorithms from those languages, and also through the embedded R and the embedded Python capabilities to make callouts where you need to do something that we don't support inside the database. And we also have some new functionality called Oracle Machine Learning Services for model deployment beyond the database and for modeled monitoring. So at this point, we're going to walk through an example where we're going to predict voluntary employee attrition using Oracle Machine Learning, and I am going to hand it over to Derek in a second, but I guess I'm supposed to just talk about the overview here. The overview is we're going to share a simple case with a ADW Oracle Machine Learning Application Express, and then we've added in the Oracle Analytics Cloud at the end. And based on a bunch of historical data, and I think we're using the Kaggle data set here, we're going to build, Derek's going to build some models. He's going to explore the data, identify key attributes, build models, and then apply the models, and then we're going to take it a little bit further. So at this point, I think I'm going to hand it off to Derek. Take it away, Derek.
Thanks, Charlie. Derek Cameron here. I work in developer innovations for North American sales. And today I'll show you the Zeppelin notebook that I built for a large customer who had HR data, and they wanted to identify factors that might affect the attrition, why somebody might leave and why they would stay. First of all, Zeppelin notebooks and Oracle Machine Learning comes free, as Charlie said. You can access it directly off the console here. This is the autonomous data warehouse database. I've created an autonomous data warehouse version. You click on the service console, and then on the service console, you go to development, and you access directly machine learning notebooks. So it's available on every single database. You don't have to configure it. You don't have to set it up. You can simply click on this. And after I finished showing you the notebook, you'll see Oracle Apex. Oracle Apex as well is available and accessed directly off the database console. So getting back to the Zeppelin notebooks. So as Charlie said, you know, the machine learning functions are embedded in the database. It's in every database version. If you're running an on-premise database, you can run and create models and create prediction models and predict values in your data sets. It's in Exadata. It's you know, in the cloud, on-premise, so it's really ubiquitous. The one that I'm going to be using today, though, is the autonomous database version. This particular notebook I created in about 4 hours. I've added to it since I initially created it for the customer. It is very, very simple to take a template, usually start with a template like this, and then simply modify it to suit the use case that you're interested in solving. Zeppelin notebooks are very common. They're used increasingly by data scientists to create models, to share the results of the models with other people in the organization. It might be, you know, the models might have been created by data scientists, but there's others who might be interested in the results. And so this is a great environment that combines narrative, it combines imagery, it combines the code, all of these things in one place, where previously, without having notebook technology, you'd have different tools for different facets of the model building process. So typically what we do when we create a model, we go through a process. We understand the business, we take a look at the data, we prepare the data, we build our models, we evaluate those models, and then we deploy them. And so we start by looking at the data itself. This particular data set's quite intuitive. The idea is to predict whether an employee will stay or leave. We have a data set to build our model upon. These employees, we have a data set here where we had employees that worked for a company. They had different attributes. Their age, we knew about their age, the department they worked on, how far they were from their employment location, how satisfied they are with their job, their gender, their rate of pay. All of these things are intuitively predictive when it comes to leaving. I mean, if their employee performance as well is relevant, because if they're a high performer, you're going to want to incent them to stay, versus other lower performing employees, you won't be quite as concerned. So we're going to take this data set, we're going to build some prediction models, and we're going to evaluate those models. We'll pick the best one, and then we'll use it to predict for new employees. So the first, as I described above, the first thing we do is take a look at the data. We just get a feel for it. We don't just throw models at any old data. We need to understand that data before we create the models. You can see here we have 1,233 employees that stayed. We have 237 that left. We look at it by age. Attrition by age varies, often due to where they are in their career. Usually more churn in the beginning, less churn at the end until they retire. We look at it by job role. We look at it by performance rating. This is just getting a feel for the data. We have different visualizations as well. Zeppelin provides text-based visualizations, charting, pie charts, area charts, line graph, and this one is a scatter chart. Very simple. Click. You create. You change your display type, and you just drag the items to the different axes. So super simple to visualize the data. This isn't as comprehensive as OAC. You're going to see some amazing things in OAC that'll allow you to take visualizations a lot further. But during the model building process, it's really helpful and useful to have everything in one place. We also typically do binning. We look at the data and we bin the different variables. We have binning functions, which is great. This all comes with Oracle Machine Learning. Binning, their data mining transform functions. You can bin it, you set the bin numbers, the bin width, different types of bins. So that's all baked into the database. You don't have to pull it out. You don't have to, run code outside the database. It's also extremely fast. This took like 0 seconds to execute against our data set. Just a feature of the database is over 40 years. It's been optimized to run very, very quickly. That's just a visualization of the binned variables. I won't cover all of it. And one of the first steps we do is we take a look at the data. What are the variables that most likely affect why someone would stay and why someone would leave? And so we have our first mining function. It's called an attribute importance algorithm. We're going to apply it to the employee attrition table, and our target column is attrition. Why are people going to attrite? Well, the top reason is overtime, then job level, monthly income, and so forth. I showed the top 8, but it does it for all the columns right down to the lowest one in terms of prediction capabilities. We also have some great there's endless SQL functions in the Oracle database. One of the ones I discovered that is very useful in data mining is the DBMS stats summary function, and it just spits out all kinds of statistics related to the different variables. Great for identifying attributes that may or may not have a bearing on what we're trying to do here. And I won't go through every single pane here, but you can see here looking at numeric columns, distinct. We can look at cardinality as well, min, maxes, standard deviations. Often data scientists stratify and take a look at the data before they create their models, and that's what we're doing here, leveraging the database features. We also often correlate columns, because highly correlated columns can create what we call sort of noise in our models. And so we want to identify highly correlated columns and remove them so they don't degrade the model quality. And we create a training and test data sets. We split them. And now let's get down to the actual model construction process. Super simple. I created 5 here: naive Bayes, generalized, linear model, random forest, decision tree, support vector machine. What does that look like? It's just a command. You simply execute data mining.create model 2. This is the model type, naive Bayes. It's a classification model. I'm training it on training data set. The case ID is the employee number. That's the primary key. And our target column is attrition. Very, very fast, 3 seconds to crunch through that. And then for every model, we apply it and we compute lift. And this is simply applying it to the test data in this case. This is built on training, applied to test, and then it allows us to measure the results further on. So let's scroll down a little bit further. The next phase is to evaluate the model, and there's many measures to do this. I'm not going to get into all of them. Some of them are really the domain of core data scientists. I will touch on a couple of them that will be intuitive to you. Things like the cumulative gains chart. Well, what am I looking at? Well, what this tells you is that if I randomly take a 10% sample of your data, you can expect to get 10% of the employees who may leave. That makes sense, right? A random sample will get a 10% random sample should get 10% of the employees that might leave. If you apply a model and you select the employees on that sample using the model, you can expect to get, in this case, up to 50% of the employees that might leave with a 10% sample. So this tells us that using machine learning models to identify at-risk employees is going to be 5 times better than if you take a random sample. And as you move up the tree here, you can see that, say at 50%, you're getting 90%, almost 90% of the people. So this gives you a feel for the benefit of prediction models over basically random guessing. And so I'm not going to go through all of these different charts. They're used to measure accuracy. I've provided explanations as to what they're telling you. And so that's helped you if you want to understand what it is that these are measuring and what do they mean. We generate a receiver operating characteristic calculation. Again, you can go in later. You can pull this, and Charlie's going to have this posted. Go in later and identify, tell you that, oh, precision is really a measure of the ratio of the number of true positives by the sum of true positives and negatives. So you can always just take a look at that. I'm going to skim down here. Now let's get into the nitty gritty here. This particular model, a sport vector machine, is the best one we've identified. It has a 90% accuracy. 90% accuracy is really taking correct predictions divided by total test cases. That's the 90%. You can identify true positives, false positives, true negatives, false negatives, number of employees there. If we move down, we can look at the distribution of employee at risk. We can see that 825 have a less than 10% chance of leaving, and so on through the different deciles, up to the point where people that are almost certainly going to leave are down to 21, and we can target those for potentially incenting them to stay. And we can even get down to the individual case level. That is, well, for this employee number 1, they did leave. Why did they leave? And what were the factors that caused them to do that? And this is in the details, lots and lots of details that's generated by the model. Well, the number 1 reason with the relative weighting here is that they work too much overtime, they're single, they did a lot of job hopping in the past, work-life balance is poor, and relationship satisfaction is poor. The mirror opposite of that person is this person. This person is in the middle of their career. They have their job satisfaction is high. They have a high education. They've been with their manager 7 years, in their current role 7 years. And so these are the reasons why they would stay. So very helpful for identifying at a case-by-case basis. Then we go on to apply the model to our data. I'm not going to go through all these charts, but these are predictions. Predictions by years with company, predictions by years with current role, and comparing employees who are earlier in their career with late in their career, and what are the factors that cause them to stay and leave. And they are different, right? These are different types of employees. Very useful for identifying those differences and targeting different types of employees for incentives. So since overtime affects attrition across the board, what can we do about it? Well, the great thing about SQL, if you're a guy like me, I'm a SQL person over the years. It's, you can SQL's everywhere, and you can use it in any tool. You can play what if. And so we know that with the current overtime, 69 employees are predicted to leave. But if we disallow and, get their work-life balance back into shape, disallow overtime, the number of employees is expected to drop to 7. So that's a policy change you can make. You can change overtime policy in an organization, and you can change what you can see the expected change of that on employee attrition with that proposed policy change. Conversely, if you force everybody to work all the time, number of expected people to leave goes from 69 to 218. So really interesting way to play what if on your data. And then the last thing that I want to sort of impress on you in terms of what you can do now with prediction models is, well, if somebody is even 51% expected to leave, then they're expected to leave. You might consider that that's not a very high threshold, and you're very concerned about false positives because a mistake can be very costly. A high value employee leaving is very expensive. So you might want to change that threshold so you can introduce biasing to the models and say, employees that leave, they are 5 times more expensive than perhaps incenting them to stay, and they would have stayed anyway. So how do you impose that biasing? It's great. You can simply just create a biasing table here and have those settings, and then again, play what if in terms of, well, I really don't want any false positives. I can estimate the cost of my errors and false positives to be 5 times higher. So that was just and then you can see there, then the number of at-risk employees goes from 69 up to 371. So now you're incenting many more people just to be sure that these high-value employees don't leave. So Charlie, that's pretty much it. There's some other information about how simple it is to deploy your models, very simple, about potentially running your model building and model apply against data that isn't even in the database. If it was in object storage, you can even apply models to data in object storage or in remote database through database links as well. But Charlie, I think that's probably enough for now, and I'll pass it back to you to introduce the APEX part.
Excellent. That's a great job. And for all those who are listening, Derek's notebook and Devani and Sadesh and Rosie's work and all this is going to be posted on the GitHub. So I'll cover that in a few slides a little bit later on. So thank you very much. Well, that was excellent. Thank you very much, Derek. That was super. Now we're going to go into the next phase where we're going to show the results with Oracle Application Express, with an application that Rosie's going to take us into and show us how we can look at the results we've just done through Oracle Application Express. Are you ready to go, Rosie?
Sure. Thank you. Hi, everyone. My name is Rosie Pramar, and I work as a staff solutions engineer at Oracle. And today I'm going to talk about Oracle Apex. So Oracle Apex is a low-code development platform that enables our customers to build scalable, mobile-friendly, and secure enterprise applications with world-class features. Using Apex, developers can develop and deploy compelling apps that solve real problems and provide immediate solutions. You don't need to be an expert in a vast array of technologies to deliver these sophisticated solutions. Apex uses a very simple architecture that provides zero latency data, top performance, and a scalability that comes comparatively, better than any other vendor that has. The reason that why we say that Apex provides zero latency is because it sits right on top of an Oracle database. So whatever features that come natively with Oracle database, you can access all those features with Oracle Apex. Now we're quickly going to talk about the application that we have built with Apex. So let's have a look at this faceted search that comes completely out of the box with Apex. I did not have to write even a single piece of code for getting this faceted search. So let's have a look at one of the applications that we have built. Great. Let's first talk about this faceted search capability that comes completely out of the box with Apex. I did not have to write any single piece of code to get this functionality. So when we talk about faceted search, it's basically a component that enables end users to quickly search and filter their data like never before. It basically makes users, have more better understanding of what the data looks like with just few clicks. So, for example, if you look at the facets that came here, these were the assets that came directly out of the box because the tool is intelligent enough to understand what would be the key aspects of the data of your regarding your data, and that needs to be filtered on. But the users have the capability of additionally adding the facets as they need. So in this case, for example, if I am looking for across this data set, what quickly I can just bring a use case that comes to my mind. For example, if I want to see in a particular department such as research and development, I just want to see how high is the prediction for people with job level maybe 5 and 4 and 5, and then talk about the prediction. So I can like quickly filter on data considering different aspects, and then I can get a report quickly built specific to my use case. Having said that, so we don't want our developers to think that Apex is just going to be another low code and development environment where they don't have the capability of adding additional pieces of code. So what I'm going to show next is basically this particular chart that we basically coupled the report with this kind of visualization together, writing some pieces of code to make sure we enhance the user experience to another level. So for example, now in this case, if I want to quickly view the data in a visual format, what I could do is I could again pick up these different aspects and just see that my visualization is going to dynamically change as I change the facets across the data. So this is a great way to basically enhance the user experience for our end users, and which comes like comparatively for which like developers basically have to write very little or no piece of code. Having said that, we'll go in details how we can build different kinds of visualizations using Apex. And for this, I'll pass on next to my colleague, Dhwani Seth.
Hi, everybody. My name is Dhwani Seth, and I'm a Senior Solutions Engineer at Oracle. So as we saw Derek and Rosie mentioning about Apex and Oracle Machine Learning, let's see some of the other types of graphs or visualizations that we can build with Apex. So here we have the key factors that influence employee attrition. We saw Derek showing us how he created an employee attrition attribute importance model for employee attrition. And we saw the key factors over there. And here we can visualize the same. Because Apex is directly connected to the Oracle Autonomous Data Warehouse, and we can fetch the data directly from there without having us to write or any code or connection to the autonomous database. So we can see overtime is the highest factor or attribute that influences employee attrition in our data set. And then we have job level, monthly income, and years at company, and other attributes going on. And if I hover over the graph here, I can see the value as well. So a nice feature over here in Apex that we have. So this is the horizontal bar chart that we are seeing for key factors that influence. Another type of bar chart, so the vertical chart on the left-hand side, we can have here. So here we are seeing the total number of employee attrition predictions. So we saw Derek creating a model for predicting employee attrition. And then we also saw how we used that on our test data set to predict those. So here we have those results depicted in the form of the visualization. So in our data set, we have about 416 employees that are predicted to be leaving, and then approximately 1.054K who will not be leaving us with our model that we created for employee attrition. On the right-hand side here, now we have a stacked bar chart. So what we are seeing here is employee monthly income by the different departments that we have in our data set. So human resources on the left, then research and development, and sales. And we have different colors to represent based on the employee attrition as well. So human resources, what is the average monthly income, and how many people will be basically will be staying or will be leaving the company over here. So we can get that information from this visualization. Coming down on the left-hand side, we have this pyramid where we are seeing what is the employee distribution by job role in the data set that we have. So starting from the base is where we'll have more, the highest number of distribution. So in this, sales executive job role has the most number of employees that we have are from that job role in our data set. Then we have research scientists. And finally, we have the least number of employees from human resources in our data set as the job role. And then on the right-hand side here, we have another interesting graph, which is a box plot. So what box plot depicts is, it is a method for depicting groups of numerical data, and you can have that through the quartiles. So it is a way of summarizing the data measured on an interval scale. And so here we have 3 quartiles usually. So Q1, Q2, Q3 measured. And we're seeing the average employee monthly income distribution by marital status over here. So divorced, married, and single. And as we over here, we can see all of the quartiles information for a particular marital status. What is the lowest value? What is the highest? And the median depicted as the line over here. So now I'll hand it over to Siddesh, where we'll be seeing some more employee attrition graphs and how you can quickly create these as what you're seeing here. Thank you.
So thank you, Dhwani. So now, before we go, I just wanted to show you some more employee attrition graphs to add to what Rosie and Dhwani have shown before. So this particular graph here is pretty cool because it basically shows you the attrition percentage on the y-axis versus the years at company that is grouped by marital status. You can see the legend on the right where it's single, married, and divorced. It's very cool and interesting because you can zoom in basically to see individual people. So say, for example, if you want to see the percentage of attrition around 80%. So if you want to zoom into that percentage and see how people are faring in terms of years since last promotion and job satisfaction, etc. So it's pretty interesting, and you can get a fair idea about attrition for people versus the years at company. So you can just zoom in and zoom out, which is pretty cool. And then in addition to those, just another basic graphs about attrition prediction versus performance rating and job satisfaction. So performance rating and job satisfaction, we look at 4 and 3 just to make sure that, because the fact that you can see for the 3, there are less people who are leaving versus 4, where there are more people compared to more people who are not leaving. So it's just basically comparing the performance rating with yes and no of attrition prediction. Similarly, with job satisfaction, in our data, we have job satisfaction of 1, 2, 3, and 4. So based on that, it's a distribution of attrition prediction by job satisfaction. So lastly, let me show you how easy it is to create these graphs, right? With using Apex, it's very easy. As Rosie pointed out, without having to write a single line of code, you can create graphs, you can create analysis and reports. So let me create one very quick analysis here. So if I go into the builder, the development area, so I can just go in directly from here. So if I do quick edit, I can just go directly into this page. So let me create a new region. So basically every graph that you saw in the Apex is particularly a new region. So I have to create a region if I have to create something new. And then as we are talking about in different forms, right? So we can create forms, we can create reports, we can create interactive grids, faceted search, etc. So let me create a chart just to make sure that everything is working. So for the chart, I need to obviously, since this is on the database, I have to choose the appropriate database table. So my database table that I have is new. Okay, let me do this. new employee predictions because I've already run the predictions on the OML notebook. So it's already there as new employee predictions. And once I've chosen the table, now we need to, since it's a chart or since it's a graph, I need to map the X and Y coordinates, right? So I would map it as attrition prediction, a department. So if I want to see department versus the number of people in each department that are going to leave, right? So it's count distinct, and then the value of would be employee number. So if I want to see the number of people in each department that are going to leave, so that's it. So hit save, and then hit run. So you can see that there are 3 departments. Human resources, there are 59 people who are not going to leave. There are 4 people that are going to leave. And it seems like research and development, most people don't leave within the R&D department. And then similarly with sales. So we saw like some more graphs using Apex.
That was great. Thank you, Rosie, Sudesh, and Devani. That was really excellent. Now we even have more, and we have Philippe Leon, who's going to show us some new features from Oracle Analytics Cloud 5.7 that allows us to apply Oracle machine learning models, register and apply models from within OAC, and then view the predictions, the insights from within OAC. So take it away, Philippe.
Hello, Charlie. Thanks for having us in this call. It's really impressive the power of what Oracle machine learning can do. I want to take a few minutes here to just show you how Oracle Analytics can really leverage that power and generate great business value out of it. So to begin with, I am in OAC here, and I have a data set connecting directly to my employee attrition data in the database. So you can recognize the same tables as what you've been working on OML because it's sitting in the same database. So remember, I am a functional user, right? So I'm going to spend a few seconds here to use OAC to just get a sense of the data before doing any prediction. So I'm going to run an explain feature on the attrition column. And here I will immediately get some descriptive charts showing me the breakdown of attrition, how it splits for different metrics that I have in my data set, and if there are any drivers, so basically features here driving it, like job role, overtime, or job level. I could already keep these charts and build a dashboard out of it, but let me carry on and build it manually. Here's my employee count. If I double click on it, I will see that I have about 1,500 employees. If I explain it, I will again see descriptive starts distribution of employee count by major dimension. So let me keep these charts here and build sort of a demographic profile dashboard for all my employees. So I'm clicking there and I'm going to add selected, and that will generate a dashboard right away. So within a few seconds, I was able to get to this, which is giving me some indication about the data. Now, I need a little bit more depth to understand the data. I need ratios and calculations. So I can create a calculation in OAC. I have created one. I'm going to edit it, which is just calculating the attrition rate. So if a case when attrition is yes, divided by the total of the population. So I've built that calculation. You saw the formula was quite easy. And I am just dragging it into an existing chart. So now using different axes, I can compare the green line showing me the attrition rate and the blue bar, the population of employees. So I have made this on a broader dashboard here, and you can see that by major dimensions, I have this very interesting dashboard revealing a lot about my data. And it actually took me less than 2 minutes to get there from scratch. So now I can start to look at the data and where the green line and the blue bar are interesting value. Like for instance here, sales is a place where I have a high attrition rate, and same as well for employees who travel frequently, which is not surprising. I also see that singles in my organization is a group where the attrition rate is much higher than otherwise. So I'm going to use this chart as a filter, and when I click on singles, I will constrain the whole dashboard to show the values and the visualizations only for singles. And I can see, for instance, that singles in sales have a very high attrition rate. So this is interesting because it helps me visually understand how data correlate together, and it's a quick grasp for me at understanding this before I apply the models that have been developed in OML. So now let's move on to a very powerful capability of Oracle Analytics, which is to apply the models that have been built in Oracle Machine Learning in the database. So let us first register a machine learning model from the database. So we have to select the database where we want to use the model from. So this is the one in my case. And here are the different models that have been developed by your team, Charlie. So I can see when I click on a model, what is the information about this model, what it is that it is predicting, what it is typed, what are the input columns for the models, what are the output columns, as well as its parameters. So how was it basically run? So it allows me to recognize which model it is that I'm interested in registering in OAC. I'm just going to pick this one as an example and call it my demo model. And that's it. I click register, and now this model exists in OAC. If I go into my machine learning tab in OAC, I can see my demo model right there. If I look at its properties, I will see exactly the same. In OAC, I could say, hey, I would like some people, some users to access it, some will not. I can see the same property details, and OAC even provides me with a list of views and tables that exist in the database about this model, helping me with some metadata about it if I wanted to visualize this. But that's not what we're going to do today. We're just going to consume it. How do we consume a model in OAC once it's registered? We simply create a data flow in Oracle Analytics. A data flow is a sequence of transformations on a data set. So the data set is the beginning of the story here. Employee attrition actual, that's my Oracle database data set that we looked at a minute ago. And I'm going to add a step, which is apply model. So I'm going to apply a model, and here are the models that I can pick from. And there is our database model that we registered 2 minutes ago, and that's the one I will select. So let me collapse this bottom pane and collapse the different types here, parameters. So there are 3 parameters. One are inputs. So what are the columns that the model requires? We can see the columns, the input columns here, as well as the auto mapping of the same columns in my source data set. So I could override this and select another column, but I'm not going to do this. I'm going to go with the auto mapping. There are parameters in this case just about costs. We're going to ignore this. And outputs such as prediction and prediction probability. I don't want cost. And there are also a lot of other parameters that Oracle Machine Learning provides, such as prediction details. What are the attributes that influence a given prediction for each scoring, or prediction sets, such as what is the probability for every prediction, not just the one that is the most probable. We are not going to select this. So that's it. We're ready. We can just simply save the result of this data flow, and we're going to call this demo prediction, and this will generate a table in my ADW, my Oracle database. So let us simply run this data flow right away. So let's just name it and hit run. So what's going on right now is that Oracle Analytics is pushing down all the proper SQLs here to apply the selected registered model in the Oracle database or the ADW database, and everything is happening down there. Nothing is happening in Oracle Analytics. This will simply function ship the whole load and create a resulting table in the database. It just completed. So let's see here, we now have a new data set. Before we look at the new data set, let's check the data flow quickly. If I check its properties and its history, I will see that it should have taken 21 seconds to just run. So this all happened in the database again. Now let's double click on that the data set we created, and you probably recognize the columns here. We can see the 1,500 employees, and if I split this with the prediction, I can see the yeses and the no prediction for attrition. And if I compare this with real attrition, let me put real attrition in a trellis rows, for instance, and I'll have sort of a confusion matrix. So now we see the employees that we've predicted as no and that were no, and employees that we predicted as yes for attrition that were yes. And here are the false positive or the false negatives. So that's all interesting. I can do some visualization with this, but what's really interesting is if I go back to my initial analysis on the source data, in Oracle Analytics, I can easily blend the data set. So I can join my initial analysis with the prediction data set. So I'm adding a data set. Let me click on demo prediction, the dataset we just created, and I can add it to the project. And by default, it will join. So let me go to the diagram of this. It joins these two data sets, in this case, based on employee number. I can overwrite this join, I can change it, I can fix it. But these two data sets that we just created, the initial one and the prediction one, are joined. And so now I can enrich all of these analysis with a prediction that we just created. So to speed up the demo, I have already applied different predictions with different models that Charlie's created. And I have joined them into this data set. So you can see various model outputs here, like naive Bayes or SVM and so on. And what I have done as well is I have created a calculation for attrition rate for each of these predictions. So same way I calculated the original one, I have done it, but with the prediction. And now I can drag all of these predictions, different models, into my diagram and compare the green line with the other lines. The green line is the real attrition rate. The other colored line are attrition rate for various models that were created. And here on my chart, I can compare visually which model has the most accurate prediction based on different dimensions. So if I fast forward, I have done this on several charts. I can see here, for instance, that the naive Bayes is actually much better than the SVM. And so the yellow curve indeed seems closer to the green curve pretty much everywhere. So now, same as I did earlier on, if I use a chart as a filter, I can see if this is true by different dimensions. Now I can go and do a little bit of deep analysis. So let me use this one as a filter, click on single, and let's see if for singles, both models are just as accurate. And it turns out that in this case here, the yellow line may not be as close to the green line as the purple one. Maybe in this case, naive Bayes is better. We can see at the bottom here that for the level of business travel, the yellow line doesn't really fit the green line very well, whereas the purple one does. So just to briefly recap, we started with an initial rapid analysis on our source data. Then after this, within OAC, we applied various OML models that were built as part of the database. And right after this, we were able to compare the prediction of these models within the original analysis within our data. Now, we're going to do one last thing. Instead of comparing attrition rate, we are going to look at prediction probability for each of these values. This is an output of the machine learning models in the database, and let's leverage this. So for this, I'm going to pick an example of a chart, and I will remove all of these lines, and I'll just keep the number of employees. All I will do now is to drag the prediction probability with an average aggregation on the chart, and I'll set this as a Y2 axis. Now I can see the prediction probability, but this has to be filtered for a yes or a no. So I did this already to fast forward. So here's this page where I have incorporated prediction probability on all the charts, and as you can see at the top, we have a yes prediction filtering. So this is showing us the probability for attrition by dimension according to the SVM model. So I selected only the SVM model. So no surprise, the probability of attrition for singles is very high for that model. So let me do the same here, use this as a filter and click on single and watch the other charts, and in particular watch the bottom right one. See how the probability of attrition for research and development is much higher for a singles group than it is in average. So this is a level of information that is very interesting for me to know out of each model. Now let me go on and build another final visualization with this. But if I take probability of attrition by monthly income by employee, and again, let me filter this to only attrition yes. And here is a chart, a scatter plot showing me all my employees, their monthly income and their risk of attrition. I can easily build some quick analytics on it like clusters, and I may be interested in selecting these employees that have a pretty high level of income, yet a high risk of attrition, a high probability of attrition. Instead of using clusters, I can also go with calculations such as tilings. This is a calculation building a quartile, for instance. So quartile of risk. So let me color by quartiles. Now the red ones are the high risk, yellow one pretty high, green and blue less. easy for me to slice this by different dimensions such as department and let's say marital status, for instance. So here I can see that research and development and singles is clearly an area where I have a lot of population at risk in red and yellow. I can select this, edit, and paste this data directly into any other application, give it an action framework, or just simply look at it and take action, HR action with this. So here you go, Charlie. This was what we could do with OAC within a few minutes, leveraging the power of Oracle machine learning in the database and just visualizing the results and analyzing with it. Thanks for the opportunity to share this with you.
That was great, guys. Wonderful work. I mean, it really is impressive. Now, for all of you who are listening to this YouTube, we've made this demo kit available. So there's this analytics and data Oracle user community that I'm very actively involved with, and it's a bunch of just clever, creative people that do cool things. And we encourage you or anyone to post your cool demos out there. And that's what we've been doing. So you can see there's a few other ones out here, the wine reviews data set we've done, buy insurance, a few different things. But the one we're doing today is the employee attrition .7z. So if you just go to the analytics and data Oracle user community, you can download those and take advantage of this. Also, there are many other great links for you out there. The blog series, the YouTube videos. You can follow me on Twitter. We've got a number of different hands-on labs. So all of this is in the deck of slides, and we'll probably add that. Maybe should add that up to the GitHub as well. I'm not sure, but there's a lot of resources for you. And to close, I wanted to say thank you for your time, and I hope you can continue down your journey of becoming an Oracle data scientist. We think it's such a great opportunity for people to apply all their great Oracle skills and see how easy it is to do machine learning and just grow some machine learning skills to the rest of your vast Oracle skills and become an Oracle data scientist. And with that, I wanted to thank all of our presenters today for all their great work. Devani, Sadesh, Derek, Rosie, and Philippe, thank you very much. And thank you for listening to this YouTube webinar.